IP is a website I use a lot to figure out what's going on. BarCamp.
I should bypass it.
Well, I could cover how to set up a captive portal and.
Sorry, I couldn't resist.
Yeah.
I mean, yeah, getting through the Stanford firewall would be the most useful demonstration right here.
Yeah, it's
True.
true.
I don't know enough about the captive portal system, but the easiest way to do that is to put up your own captive portal that looks and acts a lot like the one that they present, but anyone who gets on the access point goes to yours, and then they authenticate, you authenticate for them, and hooray, both of you have access. And this is so trivially easy to do. It's yeah. And even on a human interface note, like how many people in here, when you go to a website, it says this SSL cert is invalid, but you just click whatever, I don't care, I want to view this website now.
Like BarCamp one?
Yeah, exactly.
That's an example.
It's a perfect example, and nobody cares. So if they see a fake cert, they're not going to know. They're just going to click OK, even if the captive portal is behind SSL.
Or you just run out HTTP and people don't notice.
Well, yeah, exactly.
So you're saying you set up the captive portal, does that mean you have to be serving a DHCP address for whoever logs onto the network?
No, there's trickier ways to do that, and if there's interest at the end, I can show you how.
Yeah, I mean, if you're trying to get them to get directed to your laptop, say,
Yeah.
when they first get online,
Right.
it seems like it would mean that you would have to be going into their routing.
It's even simpler than that. It's a layer 2 hack called ARP Spoofing, which I can cover at the end of this. But I want to get into SSH Tunneling. So right now I go to show my IP and it tells me a bunch of information about me, most notably that this is my IP address that I'm coming from. So this is the IP address that everyone sees me coming from on the world. But let's say that for this network doesn't want me to go to CNN.com because they don't want me reading about baseball. I mean, one of the biggest problems I've read in articles about is people just spend all day reading about sports or whatever at work, not getting any work done. So they firewall off and block CNN.com. But you have a machine on Comcast at home that you can log into remotely. For me, that is this address. And if you go to download Putty, it's at putty.com, I think, or just Google for Putty. It's the first link. You want to go to this tunnels option. A lot of this probably isn't going to make any sense to you, especially if you've never used a Unix operating system. You're not going to know what X11 is. Doesn't matter. This is the panel that you really care about. And the first demonstration I'm going to use is local port forwarding. This is really useful if you're on a foreign network and they don't allow SMTP access. So you really want to check mail, or they block POP, or whatever protocol you happen to be using. You can actually just make it look like the service that you're connecting to on your local machine. So let's take, I don't know, I'm going to forward a local port 8080 to somewhere else, maybe call it google.com. And this is going to be a local port. So what happens when you make this connection to the servers? You'll get a shell, and it probably won't look any different to you. But in the background, your client is listening on your local machine on port 8080. And any connections that go to that end up getting tunneled across this SSH session, and then the endpoint connects to google.com port 8080. Oh yeah, don't forget to click add. I always forget that, and I can't ever figure out why my forwards don't work. Again, this is one of the things that no one ever reads, and they're just like, yes, whatever, I want to go to the machine.
Does this work in China too?
If they don't block SSH.
Probably. If you can get a TCP port out, you can do it. If you can get a UDP port out, you can do it. If you can get ICMP out, you can do it. So there's various different ways of not doing it. So I've logged into my home machine, and it doesn't look any different. But if I go to, on the web, localhost port 8080, I get google.com. And so if, for instance, if you're in a very draconian network and they only allow certain things out, it doesn't matter what they allow out, you can get there. You can get, as long as you can get to a machine that you own.
That runs an SSH
that runs an SSH server, right. There's other ways to do it, doing proxying and things like that. One of the techniques I've seen is they only allow port 80 and port 443, which are HTTP and HTTPS. Who says you have to run SSH on port 22? you can run SSH on port 80. And then all of the firewalls in the world aren't going to stop you because as far as the firewall is concerned, your SSH is running on what looks like web traffic.
Hello?
Packet-based as opposed to application that actually looks at the traffic.
Right.
And says, oh wait, no HTTP headers, bye-bye.
Right, and even you can get around
Fake
that.
that.
There are HTTP proxies. So you make a connection, and the firewall may be inspecting your packets and says, oh, that looks like a valid HTTP connection. I'll let it go through, and then you set up this tunnel through over the web.
Diplomatic passports.
Say what?
Diplomats use passports and they just get waved through, they don't check the diplomatic voucher, this is a diplomatic
Pretty much.
passport.
They just look at the very the first couple of bytes of your packet, and they say maybe it's okay, maybe it's not.
Like SSL VPNs.
Yeah. And if you have a VPN set up at your house, you don't need to do any of this. So I've demonstrated the local host, the local port forwarding stuff, which is really, really useful. Let me kill off this other buddy session. Maybe? Alright, so let's try that again. Are you all familiar with what a SOX proxy is?
Tell us.
It's a technology that allows you to connect to this proxy and tell the proxy, connect to this machine on this port, and it does it for you, and then you use this proxy as sort of a middleman. Thankfully, in SSH, you can do what's called a dynamic port forward, which is exactly a SOX proxy. And the benefit here is you don't have to forward individual ports to individual hosts. Like with the local port, I forwarded something local to google.com. But what if I want to go to google.com, I want to go to cnn.com, I want to read my webcomics? You have to set up lots and lots of port forwards for that, and that gets to be a pain in the ass. Let's forward port 8080 again. But this time, we just want it to be dynamic. Dynamic port forwarding does not have a destination port. Let's see. All right, so we're still going to my home machine in my apartment. Open this. One of the benefits with SOX proxies is a lot of software supports it. Your Outlook supports it, Mozilla supports it, IE supports it. For Mozilla, or for Firefox, you go to the General tab, click Connection Settings, set Manual Proxy Configuration, and you want to ignore everything but SOX host. If you put your local port 8080 in here, it will not work because it's not an HTTP proxy. It's just a different kind of proxy. So now I'm going to do localhost 8080. You need to make sure SOX 5 is checked. I'm not sure SOX 4 is supported by SSH. So we click OK, and we want to go to showmyip.com again. This time it's going over the proxy, and my IP is different. If you look at this IP address, it's going to be the same thing as what this actually points at, which is 24.6.134.183. So now all of my web traffic is going encrypted to my apartment, a network I trust a lot more than this wireless network. So this is really, really good for if you've got some new technologies, some new Web 2.0 startup, for example, that doesn't understand web security, and probably shouldn't because they're focusing on getting features and stuff done, right? So they don't have any sort of means of secure login. So you can just set this tunnel up across to a machine that you own, that you trust, and that you trust the network on, and you've got encryption even when the end host does not. I can't think of any .coms that do this right now. I ran into one the other day and I can't remember what it is. I'd show you what I meant. But wireless networks, especially the one like Stanford, if you look in Windows, it'll say this wireless network is unencrypted. And that should be a very, very red flag to you. You shouldn't do anything, even if it's over SSL and you trust it a lot, that you should not trust it. If you don't know how to set up an SSH server, or you don't have the means to, doing one at home is extremely easy. There's SSH servers for Windows, there's SSH servers obviously for Unix platforms. The one I recommend for Windows, I believe, comes from SSH.com. I think it's free, or it used to be. If the website will actually load. And again, all of this is going over, again, the secure encrypted proxy back to my apartment. So let's see. They change product names every 5 seconds. So if you go to ssh.com and click on the whatever that word is, SSH server, you can download their server. I'm pretty sure it's free for personal use. I haven't checked recently. But if you have a Unix system, you probably already have OpenSSHD. So you already have the technology that means to do this.
Suppose on your home system you can't get a static IP. How do we solve that problem?
There are free dynamic DNS hosting services. DNS.org, probably.
Would you recommend them as being a good secure host? Or
Well, that's the thing, is they're only hosting DNS. So when you go to SSH to foo.com, your query goes off the DNS's DNS servers, and they say, okay, the real IP for foo.com is your apartment's computer. And it gives you back, and your machine actually connects to that IP. So it doesn't, it's, unless you don't trust dynamic DNS's, or DNS's resolving facilities to be trustworthy, then no, you shouldn't use it if you don't trust it.
Even if you don't trust it, you're going to have a key on your SSH
Yeah,
server.
so that thing that popped up that
Yeah.
said, this is not the right machine,
yeah,
You'll get that once,
You'll
the
get that.
first time.
Mhm.
You say, yeah, I'm...
if it's ever different, then
Yeah.
yeah.
yeah. Yeah, because remembering IP addresses is silly. What else can we do? So I mentioned draconian firewalls only allowing web to certain places. If they allow web to a place that maybe you have an account on, like SourceForge.net has compiler farms that you can run whatever programs you want to just test. And SourceForge accounts are free. So you can run an SSHD server on any port on their machines and connect to it from anywhere. So there are free means to do this available to you. Actually, before I got here this morning, I was looking for a free VPN service, but I couldn't find any. There are some that claim to be free, but I could charge you, which I wonder.
Like SourceForge gives you what, like a free shell account that you can run stuff?
Sort of. It's meant to compile.
Basically, would have to check in the source code for an SSHD and compile it and start it.
You could upload the source code for SSHD, OpenSSH to it, and build the SSH daemon. Chances are they already have one built because that's how you're getting access. Compile farm. So anybody who has an account on SourceForge, which are free, you have access to the compile farm. I have not tested that you can run SSHDs on it, mostly because I don't remember my password anymore, and I don't feel like setting up another account. So the real point of the compiler farm is it gives you about 12 operating systems that you can compile your own source stuff on. So if someone says, oh, I'm using this really asinine combination of platform and operating system, and your software doesn't work for me, you can probably test it here. But you can also use this as a platform to, get some sort of secure internet, as long as you can get the source code. Let's see. There was a recent feature added to SSH. Let's see if the version I have here has it. No. Anyway, but this version lets you do is actually lets you do a real tunnel. It's actually like a VPN connection over SSH, so you don't have to worry about setting software's SOCKS proxies. You don't have to worry about local port forwarding. I haven't gotten it to work in Windows yet, but if you have 2 Unix systems, you can set this up really, really easily. If you're looking for the option, it is not in this version. -W, I think? Yeah, here we go. I've only used it once. It was a pain in the ass, but it does work. So if you need to really use software that doesn't support SOCKS and doesn't work well if you're just doing a local forward, you can actually create a new interface on your computer that works like a tunnel.
It shows up with ifconfig and all
Yep.
that.
What other stuff could I mention? I don't know, I was hoping that the network here would be a little bit more stringent than it is, which I haven't found anything that I'm not able to access. If our-
Unless you log out.
yeah, unless you log out, in which case.
Torrent ports?
They throttled the BitTorrent ports here a lot.
Well, you can just change that, you know.
Can you?
Yeah, you can set your port range and at least Azurius and things like that.
If you use encrypted, you'll get around it. Because I know the University of Washington, they do it, and we get around it by using the newest versions of the torrent clients and just encrypt everything. So they can't do layer 4, 5, 6, you know,
Yeah.
encryption.
They probably just do inspection and look at what ports you're using and just throttle that. I'm trying to think of other things. I had a list of things I wanted to cover and I covered about half of them.
So, we had some funny experiences at the camp last night trying to get online. I don't know if you can shed any light on that or not, but basically what was happening was we weren't getting DNS addresses from the DHCP server. They weren't giving us IP addresses or name servers or gateways or anything. So I wasn't sure if this is a form of security or if they're
broken.
yeah, they're just broken for some
Relying
reason.
on machines to be in a DHCP server's config to make your network secure, anybody with a laptop can set their IP statically. And all you have to do is just sniff a little bit of traffic and figure out what the network looks like. And assuming you know how to do that, you know what
That's what we
your
did
settings should look like.
with Kismet, so we could see what some of the IP addresses were on the network, or NetStumbler, I guess, if you're a Windows person.
Yeah. That's actually how I get access at a lot of airports. Is they'll have some stupid filtering that is half-assed and doesn't work well, and you can just look at traffic and look at the network layout, figure it out what it looks like, find out what the gateway is, and then now you have free internet access.
Plus, it gives you something to do away with.
Yeah, it's totally. Yeah, you got an hour to kill. You might as well sniff traffic, right? And actually, one of the things I wanted to cover that I just remembered is if you guys use AIM, you're on a wireless network. AIM is not encrypted.
Well, the text isn't.
Yeah,
Right.
you shouldn't use AIM. But the AIM client supports SOCKS proxies, or you can set a destination server. So I don't actually have AIM installed, but
It's still not going to work because it's still going to be unencrypted off of your SOC server through the network unless you both are sharing the same SOC server. Because you got two ends of it. So
Right.
you can encrypt your end, but we're chatting.
Right.
So you're nice and secure up to whatever your SOC server
Yes.
is. And I'm crap and everything coming off your
so
SOC
if I'm
server.
chatting to you and we're both in the same wireless network, it doesn't really do any good. But if I'm talking to someone in New York who's on a hopefully secure network,
Oh, okay.
right?
Okay.
So if I'm only worried about people near me sniffing my
Okay.
traffic,
Okay. I was misunderstanding. I thought you were the boogeyman sniffing
No.
the people on the wireless network.
there's only so much security you can hope to have
Okay.
on a network you don't control at all. Let's see. Oscar Port. I misspelling. That doesn't help. Thanks, Google.
Try a different search engine. Yeah, as an example.
Sorry, where did I search on this page?
Search.msn, not.
Yeah, search.yahoo.com.
Yeah, search at Yahoo, as opposed to the awful.
Oh,
That's more familiar
now I
to
know
you.
what to search.
Why is that the default swap?
There we go.
Yeah.
Because they paid them.
So what you would want to do is set up a local port forward
Google and
on port 5190. And I believe AOL offers the AIM service on port 8888 for the specific reason that some firewalls will think it's web traffic and will let it pass. And they're a multi-billion-dollar company doing this kind of sketchy stuff. So right, to do this, you would want to set up a local port forward. Again, you're gonna connect to the machine that you own or that you have access to. And you don't need root to do this on either your Windows machine or your the client or the server. So I want to forward 5190 to somewhere. Oscar dot something. Sure. And link this local port forward. Add.
So how did you find the 5190?
Yahoo
I see it.
search. I remember search Yahoo.
Port, I think it's the port.
Yeah, port 5190. So let's do. I don't actually have the aim plan installed, so telnet will have to suffice. You read that okay? Yeah. Oh, it's better. It's easier to read on that screen than this screen. Cool. So telnet will host 5190. Maybe. Interesting. Oh yeah, so it is hitting the AOL server. I guess it does authentication using HTTP now.
This feature is not implemented.
That's awesome.
Oh.
Ooh. Oh, if you just go to the website, it probably loads up AIM Express.
Very nice.
So it may not be port 5190 anymore.
5190
Oh,
maybe
it's
only the off port, but then there's another one
Yeah.
actually for the service, I think.
You learn something every day. So that's really all I have to talk about. There are other ways to do it. I have an article on my website about tunneling PPP over SSH. For those of you who are ghetto and lazy. If you're too lazy to set up a PPP or like PopTop or some other VPN client, you don't have to. You can just do it with SSH and whatever you've got on your system, assuming you're running Linux. Somewhere. Here we go. So this just runs essentially dial-up over SSH, and it works really well. And I use this when I'm away and I have a Unix system on my laptop. And it works. It does the same thing pretty much as the SSH tunneling, the -W option that I've only tried once. But I wrote this 2 or 3 years ago, back when the tunneling wasn't an option. So there are a number of ways to get around firewalls. You just need to figure out how.
So I had a funny experience trying to do this once, using just the open SSH from Unix to Unix through a firewall. It worked really well for interactive SSH sessions, but when I tried to copy stuff over SCP, transfer files out, everything would hang or get truncated after 12 kilobytes, which I found out empirically.
You were tunneling or just using SSH?
Well, I was using port forwarding.
For SSH?
Using SSH to go through the firewall onto my remote machine.
Okay, so get this Windows smaller so you can read above my head. So let's try that. I've never actually done that, so we can try. So what I've done is I have a machine at RAT that I can log into. And what I just logged into is my home machine in my apartment. I set up a local port forward for my laptop through this machine to this endpoint, and this machine's in New York. So I can connect to local port 2222, and it'll forward through this SSH session. In theory. So we should get an SSH banner, and we do. So now I'm on the endpoint machine. So this, I guess, is doubly encrypted. But so now we can try an SCP just to see if this works. So if you missed what I did, I logged into what looks like localhost, but I end up with this machine, with a shell that's on this machine that's across the United States. So
BarCamp in Stanford, just wireless,
yes,
all lowercase, caps.
all location. Weird. Oh, dash capital P. Consistency is awesome. So we just copied that file over. That it went through my apartment and to the machine in New York. And didn't end up there. That's cool. Is this the same problem you had?
It might be your path. If you're doing :bar,
I should go in my home directory.
you don't have to do like ~/bar or something like that.
Oh, wait. Never mind. I copied his bar.
Okay.
Yeah.
I'm just bad at life.
Yeah,
So,
I mean, it was working fine for small files till I got up to, for some reason, 12 kilobytes.
Hmm.
And I think it might have to do with like maybe fragmenting on a
You may have some
packet
weird
size.
NTU issues.
Yeah, I figured it all has to be in one packet for it to get through for some reason on that network. So I ended up just using like split and shard to
Oh, jeez.
split it up and put it back together.
12K chunks.
Yeah.
Oh, that's painful.
I can hear babies crying.
So I wonder if you looked at NAT traversal at all? So if you want to connect to another host you have, but it's also behind the firewall.
There are interesting tricks to get that to happen. If you can, so let's use the big terminal. I'm trying to think how to do this.
From
With,
what-
with NAT traversal, if you have two machines behind NAT and you want to get from one machine to another, and there's no like static port forward, there's no way you can get from your machine. You can get from your machine out, most likely. You can get from the other machine out, but you can't send a packet through, right? But the way NAT works, let me get that thing up somehow. Left screen, left screen.
Oh, there's a switch on the left side to, left. Keep going.
Watch the door.
Keep going? Yeah.
Heyo. All right, so right, so you really want candy, and you can get out to CNN, and candy can get out to CNN. I guess CNN stealing your candy. That works. The way that NAT works is, do we have a eraser too? I guess it's helping too much.
One over there.
There's one right here too.
Oh.
Right. So whenever you send a packet out, and this requires a bit of knowledge about how TCP and such works, is you have an internal IP, call it A, and this interface is all pretty much going to be on one IP address. Call that N1, and this is N2, without having to write giant IP addresses, which confuses the crap out of me and everybody else. So you want to connect to N2 on some port that this thing will realize that needs to go to candy. So when you connect out, you go to, let's say you go to CNN.com, port 80, which is web, HTTP. You have a source port. So when CNN.com gets your connection request, it knows who to talk back to and on what port. But the NAT device will mangle the source and destination, the source ports and the source IP addresses. It changes your source IP address to its source IP address and makes up a random number in its head and says, okay, any packets that come back in on, say, port, let's say you're connecting to source port 10. So it remaps it to port 20. So when CNN comes back to this machine and says, I want to talk to N120, this looks up in its database and it says, okay, port 20 on me actually should go to you. So how can we use this to our advantage? If you send a packet that's specially crafted out to Candy, and you have to have like some sort of center in here that can negotiate the port mappings. So you connect to N2 port 20, and Candy wants to connect to N1 port 20. The way you can get this to really work well is you tell some other third party, call it BarCamp, whatever. You tell it that you want to connect to Candy, and Candy wants to connect to you. You need to figure out some sort of way to spoof a packet out so that the NAT makes up a translation for you, maybe N1 port 20. And the same way, and this spoofs packets back to both people, and the NAT thinks you're both connected. So it's not really the reason that you can't do NAT traversal easily is because both sides have to have an established notion of each other. And the way that the connections work on TCP is you connect to Candy first, and then Candy connects back to you. But you can't make that first connection because there's nothing that the NAT's device here says goes to Candy. So Candy needs to spoof something, and then somebody else needs to figure out what that port is, and then you can send stuff to this machine on that port, and it goes to Candy.
Is that port generated, how often is that port number generated?
It's any new connection. So it's not the best. The best way to be able to do it is to have a machine here that can figure out like what can inject things is what you need to do. You need to have somebody inject something back to both people so that they know who to connect to. Doesn't always work. If the device only uses a port number to map to who it goes to, then it doesn't matter if you're both talking to BarCamp, you've got a connection established, and then all of a sudden Candy figures out that you are N1 port 20 and starts sending stuff to you, it may get to you. And that probably varies greatly by vendor.
It seems kind of bizarre that could ever work, right?
Yeah, there are NAT traversal tricks. You get into weird NAT issues with voice over IP, BitTorrent, anything that advertises port information in a higher level protocol. So you send an HTTP request to a server and says, hey, connect to me on this port. That's higher level. That's the higher level application layer data that says connect to me on a lower level of the network. BitTorrent does this. Voice over IP does this. Both of these have extremely bad issues with NAT traversal. And there's no good way to do it that I've found whenever I needed to do it.
Yeah, I mean, it seems like I open up something to CNN.com so I can listen on N1:20.
Right.
I definitely don't expect somebody that's not CNN.com to come along and start talking to me on that port. It's just something that you have to do like during the TCP/IP setup.
Right. What ends up happening is you need to connect to Candy, and Candy needs to connect to you, but the destination of that needs to be the same as your source. And there are lots of nasty ways to do that. I've never seen an all-in-one, here's a package that will let you do NAT traversal, because a lot of them do it differently, and it's very difficult if you can do it. You may be SOL. One way you can probably do it is through a tunnel. You tunnel to one point in the middle, and somebody else tunnels to that point. You create a virtual network, and now you can both talk.
That seems like it should work, right? I mean, if you have an SSH tunnel and you're calling it ETH5,
Yeah.
and both of you guys are doing that to the same host in the middle, you should be able to just route packets back and forth through there.
Yeah.
Huh.
One of the other ways I've found to do NAT traversals with IPv6. and it's not the way you think. You may think. With IPv6, if you don't have an IPv4 address, and you want to get one, you have to go through a tunnel, what's called a tunnel broker. It's pretty much some .com that has a connection to the real IPv6 network. And what you do is you set up this tunnel over probably UDP to that tunnel broker, and then that goes out to IPv6. So if both of you are running this tunnel brokerage software, and so you end up having this tunnel that actually goes over UDP, but it encapsulates IPv6, so you can both talk to each other. But you have to have this pre-established connection somehow.
In theory, you can do that with any darknet. It doesn't have to be a tunnel brokerage system.
Right.
Yeah.
Any darknet?
Well, so any kind of system which exists independently but can still accept connections from the general internet.
Yeah.
Okay. My own private internet.
Yeah.
So if both of you can talk to the same host, then you can use that host as a sort of proxy. I've never tried to do it because I've never been in a situation where I've got NAT on both sides. But IPv6 is definitely an easy way to do it. Well, if you have any general questions, I'd be happy to field them. What was